Okay, Arduino phase 2, right? So, the question becomes, do you remember last time? Last time we introduced the Arduino and you had a little bit of a look at the integrated development environment. We went through different kinds of hardware, right, that can go with it that you're going to have to deal with, all different kinds of parts, shields which fit on top. Those things are called DuPont wires. Okay, so first thing we need to do, what we're going to do is we're going to load the integrated development environment on the computer, start it, connect it to the Arduino, configure the IDE to the particular Arduino, right? Configure the comms with the Arduino, load and test a sample sketch. The local programs are called sketches. You've all loaded software before, so I'm not going to go through all those horrible loading software things you have to do. In your packet of information, right, you have a handout called Arduino IDE. It's the largest one, it's the first one, right? If you need help in loading, you just read right through that thing, okay? So, and that's it. That's what it looks like for those of you who don't know, okay? Instead of going out to the internet, however, on what that thing tells you to do, we're going to go to that thumb drive that I gave you. So you stick that thumb drive in there. Yep, it's right there in front of your power strip. Stick your thumb drive in, okay? And you're going to connect up, you look on your thumb drive for Arduino-1.819 Windows EXE. Double click on that thing to install it. It's going to ask you all the typical questions. Do you want to do this? Say yes. Do you want to do that? Say yes. This is the wiring that you have for your Arduino is a USB 2.0, not one of these nice new spiffy ones, right? So you want to connect, after you do your install, you want to connect your Arduino up to your USB port. Now, it's relatively easy to do, right? You just match up the plugs and plug it in, okay? Moving right along. The integrated development environment, right? It's all based on a subset of C, C++. So those of you who know that, you've got an in already. All right, it's the same type of structure, same type of everything. Step 6 on your handout, your first handout, step 6, there's 2 must-haves. You must have a COM port chosen, and step 9 is you must have the proper board chosen, and it is an Arduino Genuino Uno. Okay, so let's test this Arduino that we've got here, that you've got behind. So you should go to File, Examples, 0.1 point Basics, and then Blink, and click on Blink. And you should wind up with, so I'm going to do that. I wish these two would stay together. So we're going to go to File, Examples, Basics, Blink. And there's the new code that shows up. You should have a separate window that comes up. Mm-hmm. The window that's behind it, the first one that came up that doesn't have any code on it, leave that there, okay? You can reduce it if you want to. So we'll leave that there, and there's a reason for that, okay? All right, so here's Blink. You might want to expand that, right? Make it a little bigger, okay? This is there's one LED that is hooked up on your board, that's hooked up directly to pin 13. Anyway, this is code. All it is a code that says, hey, we're going to, on the onboard LED, we're going to make it blink on and off, right, at a 1 second rate. So to load it, we go up here to upload. You see the upload arrow? There you go. It's the second one in up on the top.
Mm-hmm.
All right, click upload. And if you watch your thing at the bottom, this one is not going in either. So I'm going to stop it. You see down here, well, I just loaded it up. You see down here, right, where it says AVR dude done,
Yeah.
right? AVR is the program that talks back and forth to the Arduino from the compiler. Anyway, what that means down there, that's the AVR download upload. When he says thank you, that means everything's very nice. So right now what should be happening is you should see a light on your board blinking on and off. Which is what you have on one of your screens. You pull that up, right? The setup function only runs once when you press reset or power the board, right? And all it does is set the pin mode for that pin 13, okay? Well, what's all that stuff mean? There's a whole language tutorial that's available on the Dropbox site, right, where you can just go learn all this stuff to your heart's content. That's not what it's about. This is about getting you used to this hardware and playing with it a little bit and letting you know the different kinds of things that can be done. So, you know, the basic structure of the program is fairly simple and it has at least two parts. It has a void setup and a void loop. This is the minimum. It must contain at least these two. It can contain a lot more parts, right? Void setup you need, and that does things like
Shut her down.
It establishes your variables. You can name your you make your assignments in the setup for pins and things like that, for inputs and outputs. The loop part is where you actually do something. But notice this line right here. The setup function should follow the declaration of any variables at the very beginning of the program. So should be three pieces. If you have any declarations to make, or you're going to name any integers, or you're going to name any long, right, variables and stuff, you do that first. Then you do your void setup, which assigns those variable names to pins, or to inputs or outputs, and you tell it whether it's an input or an output. And then your void loop is where you put all your programming. So what we're going to do is quickly build a new object from spec. In your package, right, you should have a find pedestrian demand crossing traffic light statement of work in your handout package. We're not going to go through it. You know what a SOW is, but you ought to look at it anyway, because that's kind of what this is about, how you design your project. Okay?
It's usually better to plug that in after you process that.
So if you find that in there, it's going to tell you, okay, what...
Okay, you got the right one.
If you notice what it's broken up into, it's broken up into those three things that we talked about the last time, where you have to have a statement of what it is to be done, using what tools, equipment, and resources, and to what precision. And sure enough, that statement of work talks about how we're going to make a pedestrian demand crossing traffic light. Okay? So it tells you that you're going to have 3 LEDs, which are in your packet, green, yellow, and red, to mimic a traffic light, and 2 LEDs, a red and a green, to mimic the crossing signal, the traffic light for the pedestrians. And there's a push button to mimic the one that's on a pedestrian traffic light. It tells you all the tools and equipment. They're all in the little bag that you have there, and to what precision, and it tells you how the thing is supposed to operate, right? Normally the traffic light is green for the traffic. You come along and press the button, the traffic light's going to go to yellow, right, and eventually red. When the traffic light goes to red, the pedestrian light turns green, and you've got so many seconds to cross the street. And it gives you some parameters. For the last 2 seconds, that light is going to blink, the green light for the pedestrian. After that, it'll go back to red, and the traffic light will go back to green. So there's all the pieces that are in there. So now from your thumb drive, open the folder called Pedestrian Cross. Okay. And inside Pedestrian Cross folder, there is a program called pedestriancross.ino. INO is the extension for Arduino programs. These are uncompiled programs written in English. Okay? It should open, when you click on it, it should go out, whether your IDE is open or not, and create a new window. And you should expand that window to full screen. So I'm going to do exactly what I just told you. I'm going to go out here and I'm going to go to Open Pedestrian Cross, and I'm going to load Pedestrian Cross. And you see it opens up a new iteration. There you go. So we'll close all the rest of this crap. We'll take this guy, we'll expand it. You know about slamming your little windows up against the sidebars, don't you? Watch what happens when I take this window and slam it up against the side. See, it fills in that empty space. So here you are. This is your new one, okay? And you've got your Arduino all plugged in. All right. And anyway, this is the program. So sure enough, up front we have, this is where your integers and other variables are defined. And it tells you that the red car light is on pin 13 and the yellow car light is on 12, blah, blah, blah. You need this information to build it, right? So who comes first? You know, does the hardware builder build it first, or does the software writer, whoever gets done tells the other one what to do? That's a bad feature in the government, and they do that all the time. There's committee meetings. At any rate, here's your void setup, right, where it assigns the modes and the input or outputs to these variables up here, or these actually are integers up here, right? It also does something else. It starts the serial at 9600. By the way, on your one that you have open, go up here and hit serial monitor up here in the corner, and you should get this white screen appearing. Okay, did you? And you can take your program side and your serial monitor side and arrange them on the screen just like I got them. Again, this is nothing more than a separate window that you bump up against the side. Okay. So we've got it loaded. Okay. And sure enough, you go from your code to your hardware, because you still have to build this. Okay? So start thinking about this. It tells you that the red car is on pin 13, the yellow car is on 12, the green car is on 11, the green pedestrian's on 2, the red pedestrian's on 3, and one side of the button goes to pin 7. Okay, so that's information that you got from the program. You've got to keep that in your head. And we're still going. Now you got to breadboard all this stuff. You're going to need in your packet, you should have 5 2200 ohm resistors that run from each LED cathode to the negative rail. Okay, and 10K resistor from button pin 7 side to the negative rail. It's actually a pull down resistor. And a wire lead from Arduino power 5 volts to the positive rail, and a wire lead from Arduino ground to the negative rail. If you look in your packet, you should have a schematic in your packet. Yes, So pull out your schematic and take a look at it, and your board should look like that when you're done. Okay? So put little pins together.
This is the fun part, right?
This is the fun part. Now, while you're doing that, while you're putting your board together, there's just a couple of things that I'm going to talk about. Number one is LEDs. The way they're made, this is where fully understanding the whole world helps. And this is why I'm trying to tell my students who are engineering students, these are little things that you have to know. The connection with the pointy and how a LED is made, right? How an LED is made. Inside, you have the anode, which is the positive, and its lead tapers to a point. And then you have the cathode, which can be a bunch of different shapes, but it doesn't come to a point. If you are reusing an LED that's got clipped leads on it, so you don't have a long one, or it doesn't have a flat side, so you can't tell it that way, how do you identify, how can I use this LED? If I put it in backwards, you know it's going to happen, and that's the end of it, right? So you use a magnifying glass, and you grab a hold of the LED, and you look at it, and look at that. There's a pointy end and a not pointy end, right? That pointy end is the anode. You'll notice it corresponds to the long lead. So, start putting your stuff together. Okay, that's one. Number two is that push button, right? The push button is square, but if you take a look at it, right, it's got two sets of the sides where the pins come out, okay? And like a dual inline package, not like it, but if you look at it that way, at one side, the tabs that are, or the pins that are internal to the button, they're connected right across the button.
Success.
So don't turn, when you put the thing on your, the button on your board, don't turn it the other way, otherwise you're going to create a dead short, okay? Because you'll be crossing the positive and the negative rails together. And your computer 5-volt supply won't last long. So you look back at your picture of your schematic. Anyways, when you're all done, who's done? Told you this was this is a fun part, huh? That starts a chain of events, right? That handles 5 different, actually 6 different things. It handles the changing of all 5 lights, and it causes one of them to blink, right? So that means that you can use this for anything like a crossing gate or a, you know, in model railroad stuff, but you can use it for the concept of it for a whole bunch of other stuff. And that's why we give you the code, we give you the picture, right? But like I said, when you can take that code and explain what it's doing to other people, right, then you really understand it.
That's cool.
Well, I hope you enjoyed it, okay? I hope you learned something.